In domain-driven design, or DDD, we hear about things like aggregate roots, domain events, entities, value objects, and repositories. Now, before we dive into what those are, it's worth noting that DDD is not fundamentally about these technical details. It just says that the structure and language of the code should match that of the business domain. It's about creating a language shared by domain experts and technical experts, so that the words used in the business area are the same words used in the code. We use this language to build a rich model of our domain, describing the objects, interactions, and business rules in terms that everybody understands. But, perhaps ironically, we use these technical terms to describe the types of objects we often find in that model. First, let's take value objects. If, for example, we have two color value objects with all the same RGB values and ask, are these equal? The answer is true, because they are the same value. Purple equals purple, even if we compare two different instances of it. These objects do more than just contain data though. They help express business rules. In this case, for example, we could ensure that the RGB values cannot be negative. Value objects are immutable, which means we cannot modify their properties. It doesn't make sense to say this purple is now orange, because this purple is defined by the fact it has these RGB values. We can't change that. Entities, on the other hand, behave differently. For example, let's take two tire entities. Both might have all of the same property values, but if we ask, are these equal? The answer is false. They are still two different instances. Entities can have all of the same values for their properties, but they're only equal if they have the same identity. Usually they have a unique ID property. Unlike value objects, we can change their values. This tire isn't defined by the fact it has this exact air pressure. We can pump it up, and it's still the same tire, but one of its values has now changed. These changes publish domain events. These are things that happen that are important to a domain expert. They contain values describing relevant information about the thing that has just happened. Events themselves are immutable because they have already happened and we can't change the past. Event names are often written in past tense to show this. Each entity will have its own history of domain events that have happened through its lifetime. A cluster of many of these kinds of objects that can be thought of as a single unit is called an aggregate. From outside the aggregate, we don't really think in terms of the individual entities. We don't think about manually moving each wheel and each gear. Instead, we think about driving a car as a whole. This is another entity called the aggregate route. All calls from outside must come through this one object, and nothing outside can reference the other entities within the aggregate. The aggregate defines a consistency boundary where the state of all entities must be valid according to business rules. For example, let's say this car must have a certain number of wheels. To ensure state changes are always consistent, we must save all changes to an aggregate in one atomic data transaction and then load the full state back. Otherwise, imagine we're changing a tire. If we removed a wheel and then saved the changes, and then, before we can add a new wheel, another process could load that aggregate with the missing wheel and then try to drive the car. So we think of aggregates as one unit. We load the full thing from a repository, we act on the full thing via the aggregate route, and then save the full thing back to its repository. This ensures the aggregate remains in a valid state.